What's happening for this one? They give you a sandbag. They give you a hot air balloon. They give you a sandbag. So essentially, what's happening is, right? You have, oh, why is it so? Hmm? Oh wow. Wait, oh, your document is very big, is it? Okay. You have a hot air balloon. All right. You have someone standing outside here like this, and he drops a sandbag like this. Correct. But the problem is that the hot air balloon, right, was on its way up. Right. It was on its way up. Right. As it's going up, he drops the hot air balloon. Okay. Just to give you an illustration of what happens is this. So imagine I'm on my way up, okay, and I drop this ball. Okay, what happens if okay, let's say not on my way up. Let's say I stand here, right, and I drop the ball, right? What will happen? Right, the ball just falls, right? But if let's say I do a jump, and in the middle of my jump, I let go of the ball, right? So you see what happens, huh? So what happened to the ball? What did the ball do? Right? What's the difference between me letting go here, like this, and me jumping up with the ball and letting it go? What's the difference? Correct. When I released the ball, as I was jumping up, the ball had an initial upward velocity. So that's the same thing here. When the hot air balloon is rising, right, as a person holding on to the ball, lets go of the ball's initial motion is upwards. The ball will have an initial upwards motion like this. It will go up and then it will come back down. But this person being in a hot air balloon will continue to go up. You understand this? But guess what? We don't care about the person. We don't care about the hot air balloon. The person and the hot air balloon is nothing to do with what we are looking at. We only care about what? The sandbag. Right? So after I let go of it already, whatever happens with hot air balloon, I don't care. None of our business. I only care about the sandbag. I only care about the sandbag that's being let go. So what's the initial speed of the sandbag? 10 meters per second upwards. You understand this? The question is asking you what's the velocity of the bag after 4 seconds. Right? After 4 seconds. So what's going to happen to this sandbag? The sandbag is going to go up, right? It's going to travel upwards, and it's going to travel downwards. Correct? So what will happen after 4 seconds? So if you use the equation V equals U plus AT, right? You can use it to find the final velocity after 4 seconds. So U is 10 meters per second upwards, but A is negative 10. Oh, you use 9.81, is it? Okay, so A is negative 9.81 times 4. You understand this now? Right? Okay. Now, at this point, I need to ask you, have you learned this concept called projectile motion? Did they teach you projectile motion? Didn't, right? Okay, fine. This is the basis of projectile motion, right? I'm just trying to fish and see how high level they teach you, right? But if you never heard of the parabolic motion, never hear before? Parabolic motion? No, right? Okay. If you've never heard of it before, but this forms the basis of parabolic motion, okay? But if you never heard of it before, that means they didn't give you something that, that hard, right? But this is the basics of it, right? This is to help you understand the A-level version of it, right? This is the basics. So yeah, so that's why the upwards motion is 10, but the downwards acceleration is negative 9.81. So V equals to U plus AT. You understand this? Yeah. Okay. So what's your answer here? All right. So you're working here, right? It shows that you thought that when the guy dropped it, right, the initial speed was 0. right? That's why your U became 0. You made the U disappear, correct? Okay, that was the issue. The issue is you didn't realize that it was actually going up. So it was going up and then come back down. Okay, on this? Can So that's the reason why you needed to add U to it. But in fact, it's quite wrong because you're supposed to put a negative sign here and plus U. So whoever marked this forgot to give you that negative sign in front. So sometimes the markers, right, they give you the marking, right, you can get quite confused by this. Because what do you think, if let's say I didn't explain this to you, what do you think this value will be? This will be 10 plus 9.81 times 4, which is wrong. Right? It's supposed to be 10 plus negative 9.81 times 4. Then that's the correct answer. Okay? What's the answer you got anyway? Negative 29.2 meters per second. Okay? Negative 29.2. So, you see, right? Calculate the velocity. Calculate the velocity. Your final answer should be negative 29.2 meters per second, or you can write 29.2 meters per second downwards. Can? Okay, so that will be the first one. The second one is very hard. The second one is a very annoying question. So, the second question is asking you, what's the distance between the sandbag and the balloon at the 4-second mark? So now you have to bring back the balloon. I said just now ignore the balloon, right? Correct or not? I said ignore the hot air balloon, right? Yeah. But that's because for the first part, they only ask you about the sandbag. So we focus on the sandbag. Now we have to bring back the balloon. So your job now is to do this, right? I'm going to use another color. Your job now is to do this. You need to figure out at 4 seconds, right? At the 4-second mark, how far is the sandbag away from the point of release? At the 4-second mark. How far is the sandbag from the point of release, right? In 4 seconds, right? What is the displacement? Because this is the point of release, right, guys? Point of release. Point of release, right? So if you release it at this point, I don't care about the distance. I'm not asking you to find the distance. If you see, you look at this. If I'm trying to find the distance, right? What would I be doing? I'll be finding the upwards distance, the downwards distance, and then the down. I don't want that. What I want is I want to find out how far did it fall from the point of release after 4 seconds. How far is the displacement, right? From the point of release after 4 seconds. Because for the hot air balloon, right, that one's very simple. In 4 seconds, where's the hot air balloon? The hot air balloon will be up here. Correct? How high up from the point of release? Hot air balloon. So now we will figure this one out in a while. But right now I'm asking you, so the hot air balloon, how far is it away from the point of release? Hang on, let me just tell you this, okay? This is the actual A-level question, Just to give you a bit of context, If you're thinking, walao, this is damn hard, leh. It is hard because it is an A-level question. You're not supposed to be doing this now. But I'm just trying to help you understand how to calculate this using the tools that you have. It can be done. It's just that I do not expect this for a Sec 3, Sec 4 question. It is hard. This second question is hard. But that's how sometimes exams are set. You have to understand your Sec 3, Sec 4. This is a higher level game now. And Sec 3, Sec 4, right? They expect you at a higher level. Okay? And higher level is this. You got to learn how to strategize your exams. The first questions, the first few questions, maybe the first 2 questions are meant to waste your time. It's meant to give you shock and awe. It's meant to scare you make you lose your composure, see whether or not you can come back to the rest of the questions. The back questions should be more manageable. But the first few questions are always the harder ones because that's how the A-level questions are set. A-level questions, first section, first few questions are always shock and awe questions. They always give you a big scare one. You'll be like, wow, what's this? Make you lose your composure, and then they want to see whether you can regain your composure. Your objective is try to get as many marks as possible, not try to complete all the questions in order. If you have to let go of this question, 2 marks, let go of it. Right? Not worth it. 78 upon 80 lah, never mind lah. Right? Okay? So you got to learn how to strategize. And when you know how to strategize, that's when teachers start hating you even more. Because you have learned how to ignore the hard questions and get all the easy ones and still get an A. Wow, they'll be damn pissed off one. Right? Let's work towards pissing them off. No, it's the truth. So how many meters is this? No, you see, right? You think that I'm strange saying this, right? You can ask all my other batches, they all get it as well. They all understand the game. This is the game that you're playing. Yeah. Especially since you're in IP A levels kind of stream. Right? They like to use the A level concepts and try to scare you with it. So you learn how not to be scared by it. Right? And the moment you know that they can't BS you anymore, that's when they get pissed off with you. Let them get pissed off. It's okay. They won't matter in your life anymore next time. 40 meters is correct. So from the point of release, the balloon is 40 meters away from the point of release 4 seconds later. But the question is, what is the distance? What's the displacement of the sandbag 4 seconds later? What equation would you use? Looks like you have tried using S equals ut plus half AD squared, which is correct, except again, you forgot to put in the u, so you took the u as 0. That means you almost got it right. But if you just plug in equation that get answers, right, but you don't understand why or how it works, right, also no point. So that's why I'm trying to explain to you now. Okay, so she is right to use S equals to ut plus half AD squared. So we use S equals to ut plus half AD squared. What does S stand for? Let's say I use, so now I'm doing it for the sandbag. The hot air balloon already I know is 40 meters, right? So now I need to find out how is the displacement by the sandbag, okay? All right. What does S stands for? What's that? Displacement, right? What's the difference between displacement and distance? What else? You see, right? If I ask you what's the distance traveled by the sandbag in 4 seconds, right? What's the displacement? What's the distance? The distance is the up, the down, and the further down. Correct? That means the total distance traveled. But what is the equation giving you when you use S equals to ut plus half at squared? Literally, what does this equation help you calculate? It helps you to calculate displacement. It doesn't help you to calculate distance. This equation will literally help you to calculate the final position and the initial position. That means completely ignoring the up and down. That's what this equation does for you. It helps you to find how far below it is from the release point without calculating the total distance traveled. In fact, you can't even use this to calculate the total distance traveled. Okay? But anyway, our objective is to find this portion here. So, how much then? S equals to U is what? U is 10. Upwards, right? 10 times T is 4 seconds, given 4 seconds, plus half, what's A? Negative 9.81. Right? And then 4 squared. And then you calculate this out. Work this out for me. Tell me what's our value. Negative 38.4 meters. What this means is that after 4 seconds, the sandbag will be 38.4 meters below its release point. Right? Below its release point. So it will be 38.4 meters. So at the 4 second mark, after the time from release, what is the total distance that separates the sandbag and the balloon? 78.4 meters. That's the answer for the second part. Okay? There is no better joy than to get everything right and really piss your teachers off. Really. Because what they're trying to do is always try to make you feel like you're not enough. Or you're not good enough for them. So let's work towards going against that system. Good. You understand how to use this equation now? Alright. But like I said again, this was an ACJC question in 2021. Prelims. Okay. This one? Should we do this one? What's this? Why is your lines like that? Okay. So there's a what? There's a solid line and a broken line, is it? Okay. There's a question on that one. Wait, hang on, but I don't understand why the line that you drew is slightly off gradient from the other one. Okay, never mind. We'll figure it out. So calculate the acceleration. These are no problems. What does the area under velocity time represent? Determine the area shaded in this one. So, whoa, bro, what's this, man? Right. So it represents displacement, and what's the units? You lost 2 marks because of that. This is meters per second. This is seconds. Area will be meter per second times seconds. What do you get? Meters. Have you treated your units like algebra before? So if let's say you take meters per second, multiplied by second, what do you get? Meters. Okay? It's fine. Right? There's nothing to feel shy or anything about. Right? We address it, we learn from it. Next time round, you don't make this mistake, it's fine. Right? That's what learning is all about, right? Understanding that mistakes were made and we learn. Okay. Express the distance between the two cars when both cars achieve 22 meters per second in terms of d. State the minimum value of initial separation if the cars did not collide. What? What the heck is this? When they were what? 22 meters per second, is it? Down here and this one here, is it? The separation, is it? What's the question asking for? Would that be finding the area under here? The area in between? No? Minimum value of the initial separation of d if the cars did not collide. Distance between the two. Express the distance. What's d? Sorry. What was d supposed to be anyway? What's small d, guys? Oh, they are at a distance d apart. Fallen tree in front of him, brakes hard until his speed reaches 22 after a reaction time of 0.9. Okay, so basically, part C is asking you, what should the distance be between A and B, right? If you don't want B to crash into A, right? What should this distance be if you don't want B to crash into A? You know what I'm saying? So immediately, when A changes its speed to 22 meters per second, B still is thinking. He still has a thinking reaction time. Okay? That means B will maintain at 30 and then A is at 22. B will not collide if B switches his speed to 22. Do you agree with that? If A slows down to 22 and B matches his speed, which is according to what the question says, right? Decrease, right? Right, driver brakes with the same constant acceleration and then it decreases to the same speed, then B will not crash into A. Do you agree? I mean, obviously, even better if B can completely stop, but B doesn't really stop, right? Minimally, B must reduce down to 22, right? Okay, so the thing is this, B hasn't done that yet. B hasn't figured out to slow down to 22 yet. Okay, right? So what you need to answer is, what should this distance be, right, for B to reduce from 30 to 22, right? So sorry, 30, and then there's a thinking time of 0.9 seconds, reduce down to 22, okay, reduce down to 22, and the time taken to reduce down to 22, sorry. So at 0.9 seconds, he's still at 30, and then he needs to reduce down to 22, so this is the time taken. So the question is, what's the distance that he needs, right, to be behind A in order for him not to accidentally crash into A? Okay so far? Do you get this part here so far? This thing, that's why I asked you to come down for paper review, because once I saw your questions, I realized that I cannot do this over WhatsApp. You needed to do a paper review. That means you need to go through the questions. Right? This is not something that you can easily get just looking at WhatsApp or looking at a past video. Right? So the idea here is B is still traveling at 30, okay, for 0.9 seconds, and he needs to decelerate to 22 given a certain time. Then the question is there enough distance between him for him to slow down to 22 just before he collides into A? So the question is, what's that distance that he needs? You understand so far? Can? Okay, good. So the answer to that is this. What is the area required by B, right, during the 30 to 22? This is from the 30 to the 22, this area here. And what is the distance of the 0.9 seconds before he started to slow down? This is the 0.9 seconds. What's the combined area? That will be the minimum distance required. So for 0.9 seconds, B is still reacting, B is still thinking. So B's reaction time is 0.9 seconds, but before he starts on the brakes, he will be traveling at 30 meters per second for that 0.9 seconds. And then when he starts slowing down, right? So this is the amount of distance that he needs to be in front of A. Okay? Right. But honestly speaking, this C part one, this one here you can just, it's one of those questions also you can just skip one. This one is like, walao eh, what the heck is he trying to do? Okay. I tell you what, this C part one, right? This C part one here, this one here, I think it might be a bit more complicated than that, but it's really not worth 2 marks. Okay? Right? I mean, I'm thinking of this, right? But actually, it's true lah. 30 to 22, right? Until they're 22. So it's actually this distance here. But then they have a distance and then they have the minimum, right? They have the distance and then they have the minimum value. Express the distance between the two cars when both cars achieve 22 meters per second in terms of D. Then state the minimum value of the initial separation of D if the cars did not collide. Okay lah. I'll tell you what, this one here, I show you the working. Okay? I think this part here is correct, but I'm just calculating the value. They want you to express it in terms of D. That means your answer must be something D, which is damn annoying. It's not worth 2 marks. Right? So are we okay to skip this one first? Good. All right. Part 2 though. So part 2, right? Actually, I'm a bit concerned about this. They ask you to add lines to show that the cars come to a stop, right? So shouldn't you continue with the same gradient? They say like with the same constant acceleration until the cars come to rest, right? Why is your line slightly off from the original gradients? It should be the same, right? Should it be the same? Yeah, it should be the same. Why do you all slightly deviate like that? Yeah, lah, it should be the same. No, no, you got a mark. Okay, so does it matter to you that you now know that you have to be the same gradient, right? It matters to you, right? I mean, it matters. I mean, sure, you can get a mark, but I don't know why your teacher give you the mark. Like it shouldn't be a way. So my question to you is, why do you deviate from the gradient? Like, yeah. But do you find it strange now that you deviated? Okay, can. So the correct answer is that you have to make sure there's correct gradient, the same gradient, right? Okay, that's fine then. Okay, let's move on to the next one. What's the next one? Okay, so when they ask you suggest in terms of forces acting on a hovercraft, right? I want you to consider what are all the forces acting on a hovercraft. Yeah. What are all the forces acting on a hovercraft? There's the weight, there's the normal contact force, or maybe just the upwards force by the air, mg, right? And the upwards force, right, by air, right? There's air blowing downwards, right? And then there's a propeller which pushes it forwards. This is the driving force. And then there's the resistive force, which is the air resistance, right? Wait, they have to come in already. Come. Sorry, you are. Oh, hi, Lisa. Yeah, come. You come in and sit down first. Let me finish up with them first. Did you bring your paper? Okay. Can you bring it out first? You want to sit in front? Or you want to sit behind? Depend. Yeah. So when this question comes out like this, they ask you, why is the speed now constant? Right? Why is the speed constant? So how do you answer this? So when something is at constant speed, what does it mean? No acceleration, good. And no acceleration means what? No resultant force. So your job is to explain why is there no resultant force. Okay? So since we've drawn all the forces here, right? How do you explain in words why is there no resultant force? The weight balances the upwards force by the cushion of air. The forward driving force balances the air resistance experienced by the hovercraft. There's no resultant force. The hovercraft is in equilibrium. Based on Newton's first law, the hovercraft moves with. There you go. That's what you're supposed to write for this answer. Right? They're asking you to explain in terms of forces, right? Do you see the phrase there? Explain in terms of forces. You're supposed to quote all the forces. When they ask you to explain in terms of forces, you need to quote all the forces given to you, right? Or rather, you have to infer. This one, I think, is you have to infer what are the forces, right? You have to infer those forces, and then say that they all balance. You know? Let me just finish this out with them first. Hang on. So pressure, send the video out, right? Oh yeah, yeah. So pressure, I did send it out, but I'll tell you this, I will follow up on it, right? When are you away until? Are you going away? You're not going away. Last week of December, are you going away? Because the other day you were requesting what pressure, right? You requested for pressure, which is why I sort of like sent out the videos in the group chat. I mean, no, I know. I just sent it out last night only. At what time? Was it 2 a.m. or 3 a.m.? I sent it out last night, 2 a.m., 3 a.m. Yeah, I was doing work. I was doing work with the A level students until late at night. So I sent it out just yesterday only. I mean this morning only. So I know you haven't watched it yet. What's your brother doing now? He's in army, right? He finished already. I forgot which batch he is already. Is he in university already? Not yet lah. So he's waiting, right? That means he's the. Oh, okay. I remember which batch already. Okay, can. Which school and stream are you in again? IP. Why didn't you go to MGS? Why didn't you go MGS? Huh? You didn't think of going to MGS? Oh. But the PSLE score cannot get into MGS IP, man. No, because your brother went through the IB program, right? So the question is, how come you didn't go down the IB program also? Oh, you have another sister. Okay, and she went through the A level. Okay, and does she like it? EJC? I mean, she might like EJC. Does she like A levels? That's a different question. She liked the school, yes, I understand. But does she like the A levels? That's a different question. Yeah, that's the thing. So why weren't you informed enough to go and do the IB like your brother? That's what I'm trying to get at. You see, that's the thing. Okay. Anyway, I have to continue this another time. Right. So yeah, I don't know when though. Last week of December. I'm going away end of this week. I'm going away already for 3 weeks. So I'll be back only end of December, last week of December. I'll hold one more catch up. But it's more or less to do this kind of paper reviews.